So this question is about arithmetic sequences and then about geometric sequences. This is going to be a good review, full review of these types of sequences. A quick reminder, arithmetic sequence means something like take some number, I'll just start with a 1, and then add the same number repeatedly. So I'll say add on 3, and add on 3, and add on 3, and then have that go forever. And then find a formula for the general term, which is called an. Well, first of all, what was added is called d. That's because you can subtract two of them. 10 minus 7 is 3. 7 minus 4 is 3. 4 minus 1 is 3. So the common difference is 3. Then the formula is going to be an equals the first term plus the number 3 was added on n minus 1 times. So then you could use this formula to generate this list forever. Now that's arithmetic. Geometric, on the other hand, says instead of adding the same number, like adding 3 over here, multiply by the same number. So let's say start with a 5. Now multiply by 2. And multiply by 2, and multiply by 2, continue forever. So when you multiply by 2, that's called r. R is equal to 2, and r stands for ratio. Ratio, if you divide 40 by 20, you get 2. If you divide, which means ratio, 20 by 10, you get 2. So it's common ratio. Then the formula is going to be an equals, start with the first number 5, and then multiply by 2 several times in a row. In fact, n minus 1 times in a row. So this is the general formula for an arithmetic sequence, and here's one for a geometric. Now this problem, number 97, isn't quite as straightforward because you're not just given the whole list, you're only given 2 of the numbers. So the first one is missing, and then there's an 8. That's number 2. Then number 3, number 4, number 5, number 6, number 7, number 8, and number 9 are all missing. Number 10 is the number 100. Since this is an arithmetic sequence, then the same number was added on each time. So all I have to do is figure out how many d's does it take to get to over here to the 100. So I'm not going to write d every time, but how many d's would that be? So just count the arrows. 1, 2, 3, 4, 5, 6, 7, 8. And then of course that makes sense because if you were going from the second one to the 10th one, that's 8 spaces. So in here, somebody took the number 8 and they added on a d 8 times. When they did, they got that the answer was 100. So in order to solve for d, we just need to subtract this 8 from both sides. So d times 8 is equal to 92. And then we need to divide by 8. I don't think that divides evenly. I think a 96 would divide evenly. There we go. So 92 divided by 8, 11.5. That's fine, you're allowed to have decimals or fractions. Okay, so then the formula is going to look like an is going to be the first term. Uh-oh, we're missing the first term. Well, if going to the right means you add d, then going to the left would mean subtract the d. So take an 8 and subtract 11.5, that's going to be negative 3.5. Okay, so the formula is the first term, negative 3.5, and then plus the d of 11.5, and then that's added on n minus 1 times. Now for part B, it's going to be similar except instead of adding a d each time, this one is geometric, so somebody multiplied by an r. So the setup is the same. The first one is missing, and then there's an 8, and 1, 2, 3, 4, 5, 6, Let me double check. This is the second place number, third, fourth, fifth, sixth, seventh, eighth, ninth, and the 10th number is 100. Then draw the little arrows again. This time somebody multiplied by r, and they multiplied by r, etc., etc. And then because it's going from the second one to the 10th one, that means there were 8 of them in a row. So in this case here, somebody took an 8, and then they multiplied by r, by r, by r 8 times in a row, and you could either say, literally write down r 8 times in a row, or say r to the 8th. And then they got the answer 100. This one's definitely going to be a decimal. So we divide both sides by 8, so 100 divided by 8. Usually I would say you need to reduce that, but we're going to take the 8th root of both sides anyway and get a decimal. So the 8th root, so 8 math root of 100 divided by 8 is a 1.371. Okay, so then we need to do the same thing as over here. You have to go backwards to find out what's the first term that's missing. So instead of multiplying by r, since we're going backwards, we'd have to divide by 1.371. So an 8 divided by 1.371, the first term was a 5.835. So then the formula is going to be an equals the first term, 5.835, and then the r, which is 1.371, is raised to the n minus 1. And there's the formula for the geometric sequence.